So in this video we're going to look at using Excel to draw pH titration curves and differential curves, in other words a plot of the slope of a curve. So here I have some pH data, so I've got volume of NaOH added and the pH at each volume point. And what we want to do is now draw a graph where this column A is our x-axis and column B is our y-axis. So if we just click anywhere with this blank space, click Insert and Charts. And I'm going to choose an XY scatter. Now you see here, because I've clicked in blank space, no chart has appeared. And if there are charts up here, I'd recommend that you delete them and build them yourself, because you have much more control that way. So I've clicked on the chart, it's highlighted around the sides. I'm going to choose Select Data and click Add. If you can't see Select Data, you just need to make sure you're in Chart Tools, Design. So I don't need a series name because I won't be using that. So I'm going to choose my X values. My X values will be from the first column here. Press the Shift button, click on the last column, last row. And here my Y values will be the same. Click on the first row, scroll down, Shift, click on the last row, and press OK. So I can just press OK here to see what that graph looks like. So this is pretty much our graph. This is essentially all we need, but we're just going to now work on the layout. I'm not going to put a chart title here because that will be in the legend in my report. So instead I'm going to add in labels. So we can do this in two ways. We can choose a particular layout, or we can go to individual chart elements and add components as we wish. So I'm going to choose a particular layout and choose this first layout here. Again, I can delete chart title. We'll come back to series later. So my x-axis here is going to be volume of NaOH added in milliliters. And my y-axis is going to be the response to each of those volumes, the pH. You see here that the default of Excel is to make it grey. So if I just click on the chart so that the entire chart is highlighted, and just change the font color here to be black, it just makes it a little bit clearer. You can decide whether to delete the grid lines. They're not really necessary, so I just click on grid lines and press delete. Alright, so what we want to do is format the plots. So if I click on the plot, you see here the data points are highlighted. And I'm just going to modify these a little bit just so that they look a little bit more professional. So you see in this first option here, this paint can, it gives me the option of line and marker. So there's no line in this plot, but the marker options, I'm going to say we want a no line around the option. That'll make it much slimmer. And in the fill, I want it to be solid fill and black. The actual marker size, I'm going to dial down a little bit so that it's much finer, maybe 0.2. You can see this gives us a much more elegant looking graph. Okay, let's park there for the moment, because now what we want to do is draw a plot of the derivative of this curve. In other words, if I take a tool here to draw the slope, so for example the slope at this point here, oops, that again, I'm just going to make this much bigger. So let me just go to Insert, Shape. So the slope at this point here maybe is going to be like that steepness, just make that black. The slope at this point here, so you see that the slope doesn't increase very much, but obviously at the point of equivalence, at the end point, the slope is going to be very steep. So if we have some way of plotting the slope of this graph as a function of the volume of NaOH added, well, at the point at which that slope is steepest will be at the equivalence point. So we'll be able to very accurately identify the equivalence point. So I'm just going to delete those lines. So what we want to do is find the slope at each point. Now there isn't a great way in Excel to do this, but what we can do is essentially say that the slope between any 2 points is obviously the difference in the y values between the 2 points divided by the difference in the x values, dy by dx. So to calculate the slope, I can say, well, this is going to be equals to the difference in values in the y, so the second value minus the first, and just note the brackets here, divided by the difference in value in the x's, second value minus the first, close bracket. Okay, so brackets here are very important. Now if I click on that calculation and hold the mouse over the bottom right hand corner, you see I get this black plus. If I copy that down, it will just give me that calculation repeated for the remaining values in the column. So if I click here, for example, we see it's B47 minus B46. So this value here, B47, minus this value here, B46. Alright, so now I have xy values where this is dy by dx, or at least an approximation of that. So now I want to click back on my chart, go back to design, and now select data again. So I'm going to add a new series. I'm going to call this series dy by dx. The x values will be, we're not going to take 0 value because there's no corresponding number there. So from 1 down we can copy all the way down. So click and drag, or shift on the first row, click on the first row, press shift, click on the last row, either is fine, and press OK. So if I go back to my plot now, you see we have this new plot added to the chart where we're seeing the slope of the graph as a function of the volume added, and we see this spike, and this spike corresponds to the very sudden sharp increase in slope at equivalence point. So what we need to know is, what is that value? So again, I'm just going to tidy this up a little bit using the formatting we mentioned before. So we want a solid fill. I'm going to make it black, no line, to thin it out a little bit, and the size under marker options will be much smaller. And I'm going to make a line here just so that it's obvious that we are that we see the peak. Alright, so I've just modified the width and so on there. This is just trying to make the graph, give the graph a professional look. We can find the maximum value in our range of values here, and we see that maximum value there is 12.71. So we can go down and see the 12.71, the equivalent volume, the volume at equivalent point is 50 milliliters. Alright, if you wanted to, you could be a little bit clever by not having to seek the value yourself. So we could just move this over a little bit. So I'm going to call this maximum value. Now we manually scroll down the column C to find out where that is. Well, we can actually do that just using an Excel formula. So let's find out the row that this value is in. Well, we can use the match formula, equals to match, and you see this is going to look up a particular value, so we wanted to look up this value. Where do we want to look it up? We want to look it up in this column C. So I can highlight the range, and match type, we're just going to type in 0 here because we want the exact match. Close. So you see here, this is returning the fact that this value is appearing in row number 60. And we can go even further. We can actually say the volume in this row. So we can use the index function, very similar to match. Oops. So we're going to So to index, we want to type in the array, so we want to look at this entire array. So I'm highlighting across all 3 columns. It's asking me for the row number, well, we know the row number, and it's asking me for the column number. So I want to get the volume, so that means I'm looking for the first column in this array. If I wanted to return to pH, I type in the second column. I'm going to type in 1 because I want the number from the first column in that row. And now you see it's spitting out 50. Type in milliliters there to remind myself that that's a volume. So if we know that the initial concentration, for example, of NaOH was, let's say we knew it was 0.10 molar. Oops, just put in the number here. Well then, now we know the volume, so that means we can say the number of moles. Well, number of moles is equal to the molarity times volume in liters. Of course, that's molar there, not milliliter. The molar ratio, well, let's say that this is a single acid, single base titration, so let's say something like ethanoic acid versus sodium hydroxide. So the molar ratio there will be 1:1. So that means we can easily work out the number of moles in analyte. Well, it's going to be the same, equals to this times our number of moles, the molar ratio times the number of moles. And hence we can work out the from the volume of the analyte. So let's say there was 50 milliliters initially in our titration in our analyte. We can then work out the concentration. And the nice thing about doing these kind of automatic analysis, it means we can, no matter what data we then post into our array here, all of these figures will update. So concentration is number of moles, equals number of moles divided by volume in liters. So we see our concentration of our analyte is 0.1 molar. So what we've done here is we've used the graph, the slope analysis to visually show us where the endpoint is, and here we've used this kind of numeric analysis to work out from the maximum value of that slope of this second plot, this derivative plot. We use that value to work out the concentration of the analyte. A couple of things to tidy up in the graph here. I should really go back to my select data here. Series 1 I should rename as pH titration curve, and we're good to go.